Now we start doing what we really want to do with this exercise, which is to find an estimate of the ruin probability using importance sampling. Now, what we know from the previous exercises is that the probability of ruin can be found using a mean value under the shifted probability measure. And what we actually mean by that more specifically is that we may estimate, we may simulate the probability of ruin by considering the average, by considering the sample average of certain random variables. Let's just call them psi I. And let me try to describe what I mean by psi I. So where psi I is equal to e to the r multiplied by something that we achieve using simulation. And that something relies on the increments z tilde, which we found a distribution for in exercise D. So what we want to do is, let's just try to describe what we want to do, where for each I from 1 to n, we want to simulate z tilde 1, z tilde 2, and so on until the sum of these variables is smaller than minus u. And when that happens, we then set psi I to be equal to e to the r multiplied by, well, let's just define this thing as star, r multiplied by star. And we will do that for I equal to 1, 2, 3, 4, 5, 6. And that yields us a sample of capital N of these psi's, and then we take the average of them. So how do we simulate each of these z tilde? Well, the distribution of z tilde is exactly the same as, okay, so let's just mark each of these with an I so that we know that these outcomes also depend on which I we have. So the distribution of z tilde was what we found in D, given as the same distribution as the claim size minus C multiplied by the inter-arrival time. And let's also just earmark all of these by I to be completely safe. So it might be you haven't even listened to what I was saying because you actually just need to look at the code, and let's just go through the code. First, we define all the variables as given in the exercise and notice that, yay, the net profit condition is fulfilled. Then we define R, since we found an expression for the adjustment coefficient R from exercise C. And also we have an analytical estimate for the ruin probability from the lecture notes, which is given by this expression here. And that is just from the Hans Schmidli notes on page 40. Then in my simulation, I choose 50,000 runs. So N, capital N for me, is 50,000. And for each simulation, what we do is we go in there, and then this randvar is what we call well, what is it actually? It's the sum of these z tildes. So each z tilde is simulated as the claim size minus c, which is the premium, multiplied by the inter-arrival time, and we add it onto itself so long as this Randvar value is greater than minus u. And as soon as it goes below minus u, we save it as an estimate given by the exponential of r multiplied by this thing. So I guess you can call this the thing that we call psi I out here. Now, the only thing that's left to do, since we have all the psi i's, is to find the sample average, which we do in this line here. And we get a sample average of 2.26 E05. And what that means is it's, let's see, 0.0000226, right? So that's equal to, can this be right? I think so. Yeah, it's it's 0.0226 not percent, but in Danish promille. Okay, so the analytical Rouen probability is actually very, very close. It's 0.0227. And yeah, well, we do have a little bit of error due to the simulation, but it is quite close because, I mean, the error occurs on this spot here, right? So our question now is, what is an estimate of the error? And we can actually also calculate an estimate of the error thanks to the central limit theorem. So by the central limit theorem, an estimate of the error would be the standard deviation of our estimate divided by the square root of the number of samples multiplied by some relevant fractile in the normal distribution. And if we take the 97.5% fractile in the normal distribution, then what we get is roughly an error of 1.14 multiplied by 10 to the minus 7th. And that error is also around the size of what we see in the estimate. So I hope that wasn't too confusing for you guys. If the explanation was confusing, I guess you can just try to go through the code on your own. And that was it. That was importance sampling on importance sampling using an exponential change of measure.